This comes from section 3.8 of your textbook, linear graphs and equations. So we're going to write equations for linear functions that don't necessarily supply an initial value again, and or the constant rate of change. And then we're going to translate between graphs, equations, tables, and scenarios. Just different representations. So I need you to recall that I don't know, we'll call it the new amount, or response, right, is equal to the initial plus the constant change pattern times how many times this was, which was the explanatory variable. Yeah, so here was our equation of a line, so linear equation that we were going from, or using, and of course rewritten the initial value, that's the y-intercept, or b, and the constant change is m, and the known as the pattern, and the explanatory variable, or how many times that constant change happened after the initial, is the explanatory variable, but that's x in terms of a calculator's business and textbooks, which, if we rearrange this, is mx plus b. Okay, so just to recall where all of these pieces come from, here we go. Let's dig in. In example 1, we're looking at the value of a tool. So the value of a tool was $2,700 in 2008, has been decreasing at a constant rate of $100 per year. Well, how do you know it's linear? Well, I see that there's a constant rate of change per year, so that is a really good indicator. But let's make a table of values. So what do we have? Years since 2008. Years since 2008. Got it. And the value of whatever this tool is. It's an expensive tool. Okay, 0, 1, 2, 3. We'll just go with some nice numbers here and start. It starts with a value of $2,700, and then 1 year later it has decreased by $100. So $2,600, $2,500, $2,400 with every year that passes. So in 2008, 2009, I usually like to write myself a reference here just to remember. So if it's 0 years since 2008, that's 2008. 1 year later is 2009, 2 years later, 2010. Just so that I can kind of get the connection between years since and the actual year, because we really don't like to go all the way out to 2008 just to make this linear graph. But so let's use these years since 2008 and plot these points. It goes all the way up to 2,700, and man, how many boxes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Well, if we count by hundreds, we only get up to 1,400. But if we count by 200s, we get up to 2,800 if we move our scale. So I'm actually going to do that. Instead of having our axes right here centered, I'm going to have them moved so that we have more space to graph this line. Let's label this. The explanatory variable is time. So years since 2008. And the responding variable is its worth in dollars. So yeah, whatever. Okay, let's plot these points. Oh, that's right. I'm counting by 200s. 200, 400, 600, 800, $1,000. 2, 4, 6, 8, $2,000. 2, 4, 6, 8. So at the top here, okay, good. We counted right. 2,800. Right. So that means that the one right below it is 2,600. So this is right in the middle there at 2,700. And 1 year later, I feel like I could space these out a little bit. So I'm actually going to go 1, 2, 3, 4 years since. And remember, that is always starting at 0. So 1 year later, it is at $2,600. 2 years later, it is $2,500. 3 years later, so 3 years, it is what, $2,400. 4 years later, it is oh yeah, right? Just keep going down like this. I didn't put that in the table, but I feel like I can predict the trend. I see the pattern. 5 years later here. Okay, and I'm going to use my not so ruler to draw this line. Let's see. I think it's gonna go like that. Does that look like it lines up with all of them? Got it. Okay, so, and now it's our job to write an equation. So we have the situation, table of values to keep track of our data, the graph of our data to give us a visual, and the equation of our line. Well, I'm going to go ahead and I'm going to call this T for time in years, and I'm going to call this, I don't know, W for worth. So this situation, the worth of the tool begins at $2,700, but then depreciates by, okay, what is our constant rate? Right? Depreciates by $100 T times, where T is the number of years. So if no years have passed, 100 hasn't been taken away yet. But if 3 years have passed, then 300 has been taken away 3 times. So, got it. Voila. On to the next. Example 2 is revenue from ticket sales. Ooh, but we have a graph here instead of the situation or a table of values. Okay. The first thing I'm going to do is actually the table of values because I have these points and I'd like to get them jotted down somehow. I see here that it says, I'm going to zoom in on this. Number of tickets. So, number of tickets and revenue. Uh-oh. There we go. Revenue is money brought in. So we're going to assume that's in dollars. Okay, so right here I see 0, 0. Look at that. It's direct variation situation. And then right here I see the point there. Okay, I'm just going to make these a little bit bolder so I can visually see them. Okay, and what are they? Do we think they're counting by twos? 2, 4, 6, 8, 10. Right on. Okay. What about vertically? 2, 4, 6, 8, 10. Great. Okay, so the scales are counting by twos. So we see after what number of tickets? I don't know how much one ticket is, but I do know how much two tickets is. Probably could predict one, but two tickets is $4 in revenue. 4 tickets is $8 in revenue. Huh. So if I wanted to know how much one ticket is, well, 2 tickets is $4 and 4 tickets is $8. I think they're $2 a pop. So my prediction is that there's our linear pattern. And that looks right. So right here at 1, there it is at $2. Right here at 3, boom, there it is, hitting at $6. Okay, so we're right on top of things here. Okay, so this is really going to help me now. We have a table of values. I think I could create an equation actually, because now I know the initial, and I left myself a blank for the ones that I had left off so that I could fill in for each ticket how much did the revenue go up. All right. So, let's give these some variables. Let's call this N for number of tickets, and I don't know. Do we want dollars? I'm going to go D for dollars of revenue. A lot of people use R for revenue, by the way, but whatever. So the response is the revenue, the dollars coming in, is equal to the initial amount, 0, plus $2 for every N number of tickets. Or if you prefer, yeah? So I'm thinking about this and I'm thinking, okay, well, every ticket is $2. And if you buy 4 tickets, well, then you spent $8. I wonder what this is a ticket for. Anyway, so words. We have to create a situation where this would happen. Or I could just say, each ticket brings in $2 of revenue. So if that's the case, I feel like we would get this table of values and we would get this picture and that equation. Okay. Let's do it again. Morel mushrooms. I love morel mushrooms because I'm kind of a country girl. And I didn't realize, like, I used to have friends who hunted them in the woods, but when I moved to the suburbs, I looked up how much it would cost to get them shipped here, and I was like, whoa, wow, it's very expensive. So just to send them, not to purchase them. This is not the cost of the morel mushrooms. This is the cost of just sending them to you. So they give us a table of values. I feel like we could make a graph out of this. I noticed that they don't give us a 0. Okay, all right, fine. Let's see. This goes up to 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's still 14. Okay, same grid. Should we just go up to 14? And yeah, let's. So I'm going to move the axis again, just because that will allow me to count by dollar. Okay, so the response is the delivery charge. Money, and that depends on how many pounds of morel mushrooms you want shipped to you. Okay, let's plot this really quick. So I said here we're going to count by ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 1, 2, 3, 4. Let's label 5. 5, 10, and the top is actually 14. 0 at the bottom, of course, always. And equal spacing, starting at 0. And then, should we go 1, 2, 3, 4? I'm going to space it like we did the last problem because we have that luxury. Okay, we have the point 1, 6. Voila. And 2 pounds costs $10 to deliver. 3 pounds costs $14 to deliver. Wow, it's quite steep. And I would like to see the pattern here. So what is it? Plus 4, plus 4, plus 4? Okay, because now I'm thinking if I want to go this other direction, I'm actually going to have to deduct 4 in order to know where I came, and then this value, whatever it was, plus 4 got a 6. So I'm going to tack on an extra one, 0 pounds of morel mushrooms, and that would start at $2. So there's a $2 flat fee and then a per pound fee happening here. Got it. So 0, 2. And again, I use my highly technical, beautiful ruler. Something like that. I didn't dip into the negatives. I didn't continue my line just because it doesn't make sense. A person isn't going to pay us for not buying their mushrooms. So let's see. I think that in my opinion, it's easier to come up with an equation than words, but you could be different, you know, because I'm mathy and you're arty, or like musicy, or I don't know, communicate better. Let's see here. We need some variables. I'm going to go with P for pounds of morel mushrooms and D for the delivery charge. So here I'm thinking the delivery charge, which is the responding variable, is equal to, the initial is $2 plus the constant pattern or the constant rate of change is $4, but that's added P times for every pound. So, okay, so starts at $2, and for each additional pound, add $4. Or you would add $4 P times because that's the number of pounds. Okay, and now we need words here. So there's a $2 flat fee plus $4 per pound to deliver morel mushrooms. So the delivery of morel mushrooms has a $2 flat fee. Who knows what that flat fee is? $2 flat fee. In addition to $4 per pound. Yep. And there's our word situation. Super. Let's do this one more time before we kind of change our perspective here. So example 4 is hate crimes since 2006. Oh, and we don't have a graph, we don't have a table, and we don't have words, but we are given this equation. Oh, and function notation. Thank you very much. I'm going to go H equals 22, take away 3T. And T looks like is representing years since 2006. Okay, so I'm actually going to go ahead and try to create a table of values here. years since 2006. And what? Number of hate crimes? We track these. We need to be nice to each other. Years since 2006. Okay, let's go 0, 1, 2, 3. Well, if you don't deduct any threes, then there were 22 in 2006. If you deduct 3, that's 19. If you deduct 2 threes, 19, what? 18, 17, 16. Got it. Okay, I'm seeing the pattern. So even instead of using the equation, I see this pattern happening, right? Of minus 3, minus 3, minus 3. It's going down. It's going down by 3 each year since 2006. Hey, that's good. I wonder when that... I'd like to check the date on that. Anyway, we need to start at 22 again, so I feel like moving the axes again. And counting by 2s. So this time I'm going to move them here just because I don't have a lot of space to make my label. Okay, this is number of hate crimes. And this is years since 2006. Good to go? We always start at 0, and I said we're going to count by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Got it. So, and again, I'm going to use this 1, 2, 3, 4. Okay, starting at 0, we have 22. There it is, 22. 1 year later, we have 19. So this is 20. Right below it, 19. 2 years later, in 2008, there were 16. 12, 14, 16. 2, okay. And 3 years later, there were 13. So here we go up to 10, 12, 13. Okay. Well, I think we can predict this. It's going to go down by 3, so this would be 4 years later, it would be a 10. Just FYI. Yeah? That's nice about the lines. They have a predictable constant rate of change. Very consistent rate of change. Nah, something like that. There. Yes? It's going down. That's nice. So we have a table of values. We have the graph. We have the equation. Now we just, okay, so in 2006, there were 22 hate crimes recorded. Okay. This has been going down by 3 crimes per year. It is years, yes. Okay, super. In the next video, we'll start talking about when we aren't given the initial value and whatnot. But I would want to make a quick remark before I move on and say that it seems like whatever I'm given, this table of value is always my first step because it's really good at organizing all of my thoughts, the variables and the corresponding values.